The rebuild of an engine involves the transmission. Our goal here is to fix all of these transmission parts, the main shaft, the brake drum, and the drive plate, to where everything is concentric or in line with the crankshaft. If this is cocked, you got to remember the transmission is some 80 some odd pounds and it sticks up 10 and a half or 11 inches. If this is cocked a thou down here, by the time you get up here where the fourth main runs, it's really walking around on you. So the start of that whole process is with the main shaft. And actually it's the flange of the crankshaft. We're putting a new scat crank in here, so it's true and square. In other words, the flange is 90 degrees to the bearing surface. On a regrind, want to make sure that you have your grinder understand to go and touch the flange, companion flange, to this piece and square it up. If you read in the Ford service manuals, I think it tells you if there's more than 1/1000th runout on that, 2/1000ths for sure, but I believe it says 1, that you replace the crankshaft. Well, we can't run down to the parts store and buy a crankshaft. So you, and if you've got a good crankshaft and don't want to go to the expense of a scat, you need to true up that flange so it doesn't have any runout. And the next thing then would be this main shaft bolts to that flange, and it's got to be square or straight, no cock, okay? And this is not the, this is a, I just got this here because it'll show up, but if I drag that around on a piece of emery or a piece of sandpaper, if you'll notice, it's polishing just out here on the very edge. And all of them are that way. I've never come across any that were really flat. And I think that's because it was easier for Henry Ford to cut a little bit of a dish in it than cut it square. If you cut it where it was bowed out, it would rock. Or if you cut a little bit of a dish, at least it's hitting out here on the edges and it wouldn't rock around. But these things were old and who knows what all kind of punishment they went through it. So I simply clean this surface up, and I do that over here on the lathe. I go through a centering process, get it as centered and straight and no run out, and then I take a thin pass across that flange to square it. And I want, that way there I stand a chance of having that thing when it goes down on that flange and it's held in place, it doesn't have any cock or rock. Ideal is 0. I have found that if it's a little out, a half-ish, or maybe even as far as a thou, a lot of times it'll go together. But I strive to get 0 run out up here. So here's the main shaft that we found that we're going to use. It's been lightly bead blasted. Again, probably won't show up too good because it's clean, but perhaps if I rock it back and forth, you can see the shiny spot again on the very OD of the thing. And this one here happens to measure 998, and that means very little or to no wear because 998 was the size. So this is the one we're going to use, and we'll move over here to the lathe and start that process of cleaning up this edge of the flange. Oops. Oops. High, high, low, low, back to high. So I'll put that down just a little bit. Close, Bill. I mean, we probably ain't going to get it much closer than that. That's just wiggling. Okay?
Yeah.
I mean, it's just wiggling. Now, what's wrong with that? We can get our gauge in there. Better. It's kind of easy, so I don't push on it too often. Much. That's going over the holes, interrupt the cut. So I'd expect to see that thing jumping around some.
Yeah.
So there.
Almost got to, but it's coming back.
If it comes back to 10, I'd say we're still in the wheelhouse. Well, that's really clunking all over the place. Now we're out of the holes. Just on some rough cuts. Yeah, it looks like it's back to 10. It's half the, you say a thou, you cut a half, right? So I moved to 2, so I should be cutting a thou here. Because I want to set back up just how I want that thing to read. It's moved a little bit on us, Bill. Just a little bit. We'll check it and see. We might be okay. Our old crankshaft has been ground off center. Okay? So you put this on after you get it nice and flat, but it's still got runout. And you check down here at the bottom and you got 5 runout. You check up here at the top and you got 5 runout. And it's in the same place. That means the shaft is over. Okay? So how do you fix that? It's the alignment pins that holds this in place. Okay? The flywheel and all of that holds it in place. So what you have to do is you have to trim off 5, 6, 7 thousandths or so. And then you enlarge this hole where the locator pin is to the next drill bit size bigger, which I think is 23/64. Now when you put it all together, you can slip that main shaft so you can bump it around on those pins. And then you get it all locked in place and you're happy, and you drill 2 additional holes, 7/16 20s threads into the flywheel. Here and here. So you drill through the flywheel, main shaft, and crankshaft flange. And that becomes your locator pin. And believe me, it works. Shaft. We've got a new scat crank and a main shaft that we've cleaned up and dressed up, and I can set it down on there and it just isn't rocking. I can't make it rock. So I've got a couple of extra locator pins. And the first thing I'm going to do is I'm just going to stick those locator pins in place. And I'm going to get me some hardware here, some nuts and bolts. And I'm going to Run this down snug, tight, and check to see what I may or may not have here on runout. This is just an extra step, but if you can't get the main shaft located with the locator pins onto the crankshaft and it runs true, you need to figure out what's wrong. But by verifying that you can indeed set these two pieces together and have little or no runout, 0 being ideal, I've found that you can have maybe a thou or so, and sometimes it all comes together and it's sweet. You're dealing with 87-year-old plus main shaft, who knows. So as I rotate this, I got a little bit of run out there. And up here at the top, I've got some run out. So I'm going to take a C-clamp because there is some play, some clearance in the bolt holes, and obviously there's some play in the pins because those will drop in. I'm just going to shove that thing over the direction I need it to go and see if I can get it zeroed and locked in place. Like I said, I just have it snug now, so I'm going to push it a little bit, and this takes a few just lock these down just like you would if you had the flywheel on it. Check it again. Okay, I've got, a wiggle, or just a wiggle. I mean, something that you really couldn't read with a dial indicator. And now I'll bring it up here to the top where the top bushing runs, and I'm going to do this again. And I have just a wiggle. So what that tells me is two things. One, I can center it. And two, since I have no run out here, little or no run out here, and I've got little or no run out here, I didn't miscut that flange. In other words, I didn't cut it crooked, because if it was crooked, I would have cock in it. So you're looking for two things. One, no run out and no cock on that shaft. We've selected this brake drum. This is an early drum, and I've already got it chucked up into our forejaw, and a steady rest is in place. And I've went through a process of using a dial indicator before I put the steady rest in place, and I would read for the least amount of run out that I could get at the very front of the shaft, or close the shaft closest to the brake drum, and then I've read as far as I can without getting into the keyways of the brake drum, and I've ran them out to where I've got the least amount of run out that I can get. These surfaces up here close to the brake drum, there's a bushing of the transmission drum that slides in place, so it's not necessarily round. It's close, but it's not necessarily round. And up on the other end is where the spring and the little clutch mechanism rides, and so it's not necessarily round. And then these things will also get pits in them, and they've been beat up and dinged up. You got to remember, it could be an 87-year-old drum minimum, and 100 plus that you're dealing with. So when you go through this alignment, you're trying to get this shaft with the least amount of runout to where we can bore the two bearings and everything is concentric and in line. We're trying to make that all work to where when this goes on the drive, on the flywheel main shaft combination, that everything stands a chance of rotating around with the least amount of runout where the drive plate fourth main runs. But this drum here is in pretty, it's a pretty decent drum. It's got some pit surfaces on it. We'll take a little lightweight sandpaper and just kind of smooth them down. These drums are so thin to begin with. I'm not in the fan club of turning these things down. They're pretty thin. Brake drums don't usually break too bad, but the reverse and the lows are notorious for cracking. But if you'll look in, if you can see in here, this is the lugs that the clutch discs ride in, and the Ford clutch discs were all metal, and so over the years it will cut little serrations into these surfaces. And in this case we have a Watts clutch, which is a much thicker disc, and so these surfaces really won't give us a lot of problems at maintaining a free neutral. But if a Ford clutch was in here, they can grab hold of these little ridges and tend to not completely release, and you can still accomplish a free neutral, but the car may want to creep a little bit. So we're going to put a Watts clutch in this. If I was going to run Ford clutches in it, there's not enough material here to really file those down smooth without getting it so thin that it would break out through where the drive plate attaches through the bolt hole here. So it wouldn't be a drum that I would use in that configuration. But seeing as how it's a Watts clutch, this really isn't going to cause us any problems. And it took me about an hour and a half to get this thing lined up as close as I could get it. Again, you know, if I'm reading about a thousandths run out, that means that I'm off about a half a thou. But as I rotate this thing around, it'll maintain, you know, 3/4 of the way around, then it makes a little dippy do, and then it pops right back up to where it is. So it's the best that I can do. The purpose of getting that centered is so that we can line bore those things to where it at least stands a chance of being straight up and down and in alignment. But another thing that we will do when we get, after I've got that bored, and I'm going to bore this to size. Not everybody's fortunate enough to have a set of transmission tools. Fortunately, I have access to those. You could bore it. The bearing is not round because we've pressed it in, and I've made a pass here. I don't know if it shows up on the camera, but I've made a pass in here, and this area here that's darker looking, it hasn't cut yet. But as I rotate it around, you can see where I've removed some material out of the bushing. So I'm using the boring bar to make those perfectly round. And in my case, because I have this tool, I would get that to where it was round and still not to finish size, and then I would finish it with my reamer. But like I said, not everybody has access to this tool, so we'll bore this one out. Wish the vendors. fourth main, you want a couple of 2/2000 clearance. I don't care what the book says. You can buy fourth mains. I pour my own fourth mains and cut them to size. But Lang's catalog, I think they say that you need 5 or 6 or something like that. And that's because they just offer them in a size, 3 over, 5 over, 10 over, that sort of thing. The more gap you have back there at the fourth main in that bearing surface, the more oil is going to leak through it. So it doesn't need to be a real couple of thousandths is fine. It'll leak a lot of oil if you have anything less. And of course, if you don't have it all in alignment, you need the room in there so it won't just beat out and wear out the bearing. Okay, so that's kind of the theory of what we're doing. We try to align bore the two bearings in alignment. And as an example, if I just took my tool that I have and stuffed my bearings in there and just went and started reaming it through, the reamer will follow the bushing and not necessarily make it absolutely concentric. It'll make 2 perfectly round holes, but those holes, and they will be in alignment, but rather than being straight up and down and concentric to the shaft, it might be cocked off a little bit. Well, that all shows up further out here, and from this point out to the end is what, 10, 11 inches, and it's 85 pounds or so. Any of this runout, tremendous amount of runout, and I've seen them 25, 35, 40 thousandths run out. The rascal's way out of alignment, way out of balance. The engine runs rough. And this is a process that is time consuming. If you don't have access to a lathe, don't have a friend that has a lathe, don't have a machine shop, then you may not do this. But if you have access to that equipment, it's a very good thing to do. So I've made one pass with our boring bar setup, and I'm going to rotate this around. Like I said, it isn't cutting here, so I'm going to get that out of the way. I've got a cut. It's cutting here and it's cutting here, and I need to know where I'm at. So with a snap gauge, I'm going to put that in there and come up with a size. And I'll take our micrometer. Right now I read 998. I want to finish at 1 inch. So we're going to make this cut. I don't cut this too quick. So I was zeroed out before, so I've raised it up a thou. I'm going to make a pass. We'll check and see where we're at. Okay? And it's cutting ever so slight. It's only taken off a half a thou. Oh, wait a second. I need to move it up. No, a thou should be taken off close to 1,000ths per side. And the little marks that I have on here, Bill, is just when I've cut it the first time, just kind of gives you a sense of where it's at. It's going to stop cutting that first bearing there, and it's going to pick up the second bearing there. Feel just a slight little movement. Looks like I quit cutting the first bearing. So if you brought the camera here over my shoulder, Bill, you look down at these drums, it's amazing that they even work. It looks pretty square. This looks pretty square. But all of the casting in between, it's just all over the place. And that's another reason it's hard to balance these things. There just wasn't a whole lot of good quality control went in on casting that part or machining it. Just going to drag it out. I'll kick it out of gear and I'm going to take a looky-loo. We still didn't get all of that bearing. There's a lot less of it now. Now there's something just kind of the width of my fingernail right there, but the rest of it's cut. So we'll take a measurement. We really didn't get to our 1,000ths, or at least the DRO said we didn't. So let's see what we got here. So I'm off. There's the part that didn't cut. So I'm going to come in here and measure. We're at 999. Okay. At this point, I would probably. There's a 1-2. Okay. Supposedly we were at 8. So that raised it up just darn near a half thou. And I want to take off a thou. So let's run it through here. See what we got. So I just want to make sure that when we end up with this cut, we're at that area. Oh, kick it in gear. Now I'm at 1-2, huh? Boy, it's just barely touching anything. Well, if I make it through and it stays at 1-2, we'll see where we're at. And this is a good example. We chose not to use this one because there's a lot of pitting surface in it. But you can see where the bearings were absolutely too snug and just turned the shaft blue. Okay, so they were too tight. I've seen them where I pulled these things apart and the bushing was actually even stuck to them. And it's cut, clean, 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 clean. Yeah, it cleaned up, okay, all the way across. So let's see what we got now. I'm almost at 999. We just happen to have a brand new main shaft, and this main shaft measures 998. And that, well, it says 9. So and 998 happens to be what our main shaft is that we're using. So as you can see, I can slide our main shaft right in there. And when we're done, I'll set this drum with some time saver on our main shaft that we're going to use, and it'll just go in there and kind of polish up some of the little highs and some of the little lows from the cutting tool. Because you're reaching in, even though this is a substantial bar, you can feel a little bit of a vibration. You can work on moving the tip